This chunk of ice may look pretty unremarkable at first glance, but put a match to it and something amazing happens. As reported in this month's issue of The Atlantic, it's called Methane Hydrate, and it's actually not unusual at all. In fact, there are more than 100,000 trillion cubic feet of it on Earth. Volume-wise, that's like the size of the Mediterranean Sea. Okay, well, so what? Well, for one, methane hydrate burns clean, and it has a greater energy capacity than all the coal, oil, and natural gas on Earth combined. So, could our future be powered by burning ice? Maybe. Dr. Carolyn Ruppel is the chief of the Gas Hydrates Project at the United States Geological Survey.
When you put it on your hand, it's like those old pop rocks. It kind of fizzes around because it's releasing the methane gas.
Using methane as an energy source is really nothing new. In fact, when we talk about natural gas, we're really talking about gas mixtures that contain methane. But methane hydrate is different, in part because so much energy can be packed into such a little piece.
Gas hydrate, because it is such a concentrated form of methane, when you break it down, you get a lot out.
It also has the benefit of burning cleaner than most fossil fuels, which in theory could cut down on the environmental hazards associated with greenhouse gases. Researchers use seismic detection techniques and even some electromagnetic measurements to locate it under permafrost or at the bottom of the ocean. To extract the usable fuel, they lower the pressure of the methane hydrate solid, which destabilizes it and transforms it into a gas.
And then it becomes very similar to a conventional gas operation, which is something that the private sector is very good at doing.
Methane hydrate is not a panacea to our economic and environmental woes. And while methane burns clean, unburned methane is a potent greenhouse gas, and if it leaks, it can be devastating to the environment. The USGS is confident leakage won't be a problem as long as proper precautions are taken. But the main obstacle at this point is cost.
If we find a way that we can produce it economically, that's key, and if we can find a way to transport it, it could certainly be a contributor to the total natural gas supply in some time frame, maybe a decade, 15 years.
Of course, methane hydrate isn't a replacement for truly renewable sources of energy, but it has the potential to serve as a bridge fuel while the U.S. tries to wean itself off oil and become truly energy independent.